Okay, so we have basic units like a gram, a meter, seconds, and then we also have what's called derived units. So derived units we get from doing either multiplication or division. So we take two things and we make a derived unit. But we can't do that for a basic unit. A gram is a gram. We can't change that. So a derived unit, again, results from multiplication or division. So here we have area of a rectangle. So if I take the centimeter times the centimeter, I get centimeter squared, right? If it's in multiplication or division, I have to do that to the unit. Now, if I'm adding or subtracting with the units, then I don't change those. But with multiplication and division, I have to do the same thing to the unit. So centimeter squared, that represents a derived unit. So if I just have a centimeter, that's not a derived unit. But if I have centimeter squared, that makes it the derived unit. Okay, and then volume of a cube, which we're actually going to use quite a bit. So you may want to circle that definition there, or equation. Length times width times height is the volume of a cube. So if I'm measuring volume and I have meter times meter times meter, that's going to give me meter cubed as my derived unit. Then also we have density. We talked about how density is mass divided by volume. So mass is usually in grams and volume in milliliters. So if I divide grams divided by milliliters, those don't cancel out. So my derived unit becomes grams per milliliter. So that line between grams and milliliters, I just say per to represent that. Okay, so all three of these represent a derived unit because it became that way because of the multiplication and division. Okay, so volume, again, we're going to be using that quite a bit. Length times width times height, so make sure you remember that. But I wanted to show you some things here. 1 liter is equal to 1 decimeter cubed. So that's a great way to go from a distance measurement to a volume, right? So decimeter, meter is distance, but volume is liters. So we don't use that one a whole lot, but we do use 1 milliliter is the exact same as 1 centimeter cubed. We're going to be using that quite a bit. So I want you to remember that, circle that, highlight that. And the one in the middle, 1 liter is equal to 10 to the third milliliters. That is one of our prefixes, okay? So we're not going from distance unit to a volume unit like we are on the other two. They're both volume. We're just changing it using that milli prefix. Okay, so density is mass divided by volume, and usually the units for that are going to be grams per milliliter. In another chapter, we're going to be using grams per liter, but in this chapter, your unit should be grams per milliliter. So just to give you an example here, calculate the density of mercury. So density, mass divided by volume. It says it's 100 grams, right? 100 grams is the mass. The volume is 7.36 centimeters cubed. And remember, centimeters cubed is the exact same thing as milliliters, so I could write it either way. And that's equal to 13.6 grams per centimeter cubed. So that's my derived unit right there, grams per centimeter cubed, right? So I have to write my number with my unit as well. So not all density questions are like this. This one's pretty easy. I just take the mass divided by the volume. Once we start adding in length times width times height, adding in conversions, density questions can get a little bit tricky, but this is just a very simplified version, okay? Just to point out as well, if I have Density and volume, I can solve for mass, right? So density times volume, I just rearrange the equation. And if I have mass and density, I can solve for volume. Mass divided by density. So I can rearrange this equation. As long as I have two of the variables, I can solve for, or two of the variables, I can solve for the unknown third one. Okay, so I keep talking about significant figures. Well, now let's look at what are significant figures. Okay, so any number that's not 0 is significant. So this first one we have 3.334. So there's no zeros, so all three of these are significant. So 3 sig, I'm just going to put figs, sig figs. Okay, that represents significant figures. Okay, so zeros are where it gets tricky. Okay, so the second one says zeros are significant when between other non-zero digits. So if you have a 0 in between two numbers that aren't zeros, that is significant. So those are easy to spot, right? In between there. So we have a total of 4 significant figures. Okay. Now, trailing zeros or zeros past the decimal point get a little tricky. But if it's to the right of the decimal and to the right of a non-zero digit, the 0 is significant, okay? So we know this 0 is significant right there because it's in between the 3's, right? This 0 is significant as well because it's to the right of the decimal. So decimal's right there, and it's to the right of a non-zero digit. So you need those two things, to the right of the decimal and to the right of a non-zero digit. So we have a total of 5 significant figures here. So 5. Okay, on this next one, the zeros are to the right of our decimal, right? There's the decimal. Let me go back here. This is in my way. Okay, to the right of the decimal and to the right of a non-zero digit. So all 4 of those are significant. So we have 5 again. So 5 total significant figures for both of those numbers. So again, always to the right of the decimal, to the right of a non-zero digit. Okay, now here on this next one, zeros are not significant when left of the first non-zero significant figure, okay? So here's our decimal. Okay, this 0 is to the right of it, but it's not to the right of a non-zero digit, right? There's only zeros. So these two zeros here are not significant. We call those placeholders. They show us that we have a small number, okay? So really the only numbers that are significant are the 2 and the 3. Those zeros are not. So we only have 2 significant figures here. Okay? And then ambiguous zeros are not significant. Again, they're called placeholders. They show us in this that we have a large number. So this 12,000 number, because there is no decimal, only the 1 and the 2 are significant, okay? Now, if there was a decimal right there, then it would make those zeros significant. But since there is no decimal, we only have 2 significant figures. So 2. And then we know that these zeros are significant because they're in between the 2 and the 1. So we have a total of 5 significant figures here. Okay, and then exact values have infinite number of significant figures. So we're going to be using more of that with our conversions. But 12 eggs is equal to a dozen. That's an exact value. So I have infinite number of significant figures. 7 days are equal to a week. So we're not going to worry about that right now. We'll talk more about that when we do conversions. But just know that they do have infinite number of significant figures. Okay, let's do some examples and then we'll move on. So first one, 8.20. So here we'll have 3 significant figures because this 0 is to the right of the decimal and to the right of a non-zero digit. So we have 3 sig figs. Okay, let's do this one here. Okay. Okay, so here's our decimal. Okay, to the right of the decimal, but our non-zero digit is right here, the 1. So all of these zeros right here before that are not significant. But these zeros, they're to the right of the decimal and to the right of a non-zero digit, so they are significant. So we have a total of 4 significant figures because we have the 1 and the 3 zeros. Okay, and then we have 12. Okay, here we have 12,000. Okay, so if there's no decimal, remember these are not significant, so we only have 2 sig figs. But if I were to say 12,000 and put a decimal, then I would have 5 sig figs. Those zeros would be significant. So the decimal changes everything. Okay, what about this number? 100,000. Now that kind of looks like a 0. Let's try that again. That's better. Okay, 100,000. Okay, there's no decimal, right? So there's all these zeros are insignificant, which gives us just 1 significant figure. So that's a terrible number, but only the 1 is significant. Okay, we'll do one more. Let's do this one. Okay, so we have the decimal here, but our first non-zero digit is here, so these zeros are all not significant, but all of this is significant, right? That 0 is in between 2 non-zero digits, so we have 3 sig figs.